The largest mass extinction event in Earth's history is known as the Permian-Triassic extinction event, often referred to as the Great Dying. It occurred approximately 252 million years ago, marking the boundary between the Permian and Triassic geological periods. This catastrophic event resulted in the loss of an estimated 90% to 96% of marine species and 70% of terrestrial vertebrate species. The Permian-Triassic extinction event was a profound turning point in the history of life on Earth. It is considered the most severe extinction event ever recorded, with a far greater impact than other notable events such as the Cretaceous-Tertiary extinction that wiped out the dinosaurs. The causes of the Permian-Triassic extinction event are still a subject of scientific investigation and debate. Multiple factors likely contributed, including massive volcanic eruptions, climate change, oceanic anoxia, and the release of greenhouse gases. These events led to significant alterations in the Earth's atmosphere, climate, and oceans, causing widespread devastation across various ecosystems and leading to the demise of numerous species. The consequences of the Permian-Triassic extinction event were long-lasting and shaped the subsequent evolutionary history of life. It took millions of years for biodiversity to recover and for new species to emerge and fill ecological niches left vacant by the extinct organisms. The event serves as a poignant reminder of the vulnerability and resilience of life on our planet. Several major geological events are believed to have contributed to the Permian-Triassic extinction event, the biggest mass extinction in Earth's history. These events include 1. Large-scale volcanic eruptions. One significant contributing factor was the extensive volcanic activity that occurred during the Permian period. The eruption of the Siberian Traps, a vast igneous province in what is now Siberia, released enormous amounts of lava, gases, and aerosols into the atmosphere. This volcanic activity caused widespread environmental disturbances, such as the release of greenhouse gases and the creation of acid rain. 2. Climate change. The massive outpouring of volcanic gases and aerosols resulted in dramatic climate changes. The release of greenhouse gases, particularly carbon dioxide, led to a rapid increase in global temperatures. This rise in temperature disrupted ecosystems and led to changes in oceanic and atmospheric circulation patterns. It also contributed to increased weathering and acidification of the oceans. 3. Oceanic anoxia. The combination of climate change, volcanic activity, and nutrient runoff from the continents likely caused widespread oxygen depletion in the oceans, a condition known as anoxia. The lack of oxygen in the oceans led to the death of marine organisms, particularly those dependent on oxygen-rich environments, such as coral reefs and other shallow water ecosystems. Anoxic conditions also promoted the release of toxic hydrogen sulfide gas, further exacerbating the extinction event. 4. Global ecosystem disruptions. The combination of volcanic activity, climate change, and oceanic anoxia severely disrupted ecosystems on a global scale. Habitats were altered, food chains collapsed, and species were unable to adapt to the rapidly changing conditions. The cascading effects of these disruptions led to the extinction of numerous plant and animal species, including dominant groups such as trilobites and many marine reptiles. 5. Feedback loops and positive feedback. Once the extinction event began, it likely triggered various positive feedback loops that exacerbated the crisis. For example, as organisms died and decomposed, it released more greenhouse gases, further amplifying climate change. These feedback loops may have prolonged the duration and severity of the extinction event. It's important to note that the Permian-Triassic extinction event likely resulted from the complex interplay of multiple factors, and the precise sequence of events and their relative contributions are still a subject of scientific investigation and ongoing research. The Permian-Triassic extinction event, also known as the Great Dying, caused the extinction of numerous dominant life forms across both marine and terrestrial ecosystems. Some of the major groups that became extinct during this event include 1. Trilobites. Trilobites, a diverse group of marine arthropods that had been flourishing for nearly 300 million years, disappeared completely during the Permian-Triassic extinction. They were among the most prominent and successful creatures of the Paleozoic era, era. 2. Brachiopods. Brachiopods, marine organisms that resembled clams but were not related to them, suffered severe losses during the extinction event. While some species survived, many dominant forms that had thrived for millions of years were wiped out. 3. Fusellinids. Fusellinids were single-celled organisms with intricate shell structures that inhabited the oceans. They were abundant and played an essential role in marine ecosystems during the Paleozoic era. However, they became extinct during the Permian-Triassic extinction. 4. Reef-building organisms. Extinction profoundly impacted reef-building organisms such as tabulate and rugose corals, which formed extensive reefs in ancient seas. These once thriving ecosystems collapsed, leading to a significant loss of biodiversity. 5. Dominant marine reptiles. Several groups of marine reptiles, including the large and diverse group of marine reptiles called ichthyosaurs, experienced substantial losses during the extinction event. These reptiles, which had adapted to life in the oceans, disappeared, leaving behind only their fossil remains.